Hi there, my name is Dusty Rhodes and you're welcome to Amplify, the Engineers Journal podcast.
We engineers were very inquisitive people. We do like to break things from time to time. That's necessary, because then you have to fix them afterwards.
Today we're meeting an originator in Irish telecommunications, the man who has helped drive transformation in the industry from the early days of ISDN to the complexities of 5G, AI and even quantum computing that we have today. As a former chartered engineer and network architect with eircom, he's been at the forefront of critical infrastructure decisions, and his work has influenced not just here in Ireland but in international standards as well. He's here to share some of the stories from his brand new book, Evolution of Telecommunications, which is an ambitious guide to comms from Morse code to the future of our connected world. I'm really looking forward to having a grand old chat with Brendan Kearns. How are you?
I'm good, Dusty. And how are you doing today?
Brendan, you've spent an awful lot of your career with eircom and you've been in telecommunications and phones. And I kind of really wanted to start this bit by asking you about the telephone, because most people are probably listening to our podcast on a smartphone. They're everywhere.
Yeah.
Is it true that the telephone, way back when, was invented by accident?
Actually, that's true, because let's put it in context. The telephone was invented by Bell in 1876. The Morse code, the Morse telegraph itself, was invented in 1844 by Morse. So there's a gap there of 26 years. When Bell was working on his experiments, he was trying to improve the telegraph. He wasn't trying to invent a phone.
And the telegraph is with the Morse code, so you're just doing the...
That's right, yeah. I would think that the telegraph really was inevitable. It had to happen somehow.
Yeah.
There's a system in France, for example, called the CHAP, CHAPP system, where they had about 500 towers, physical towers around France. And there was signal from one to the other. And physically, with flags and with pointers, they had the ability to get messages very quickly from one place to another. In the time of Napoleon, actually, when Napoleon was planning his invasion of England, which never happened, of course, he asked for this system to be available at night time, and they tried their best, but they couldn't. So it was a good system for the day. And there are many other types of systems on a telegraph which were all superseded by Morse code.
So Morse code was the currency of the day, and all that kind of stuff. What was the accident then that happened that changed it from those dots and dashes into voice?
They were working on a system, Bell and his colleague Watson were working on, where they would be able to send multiple messages over the same telegraph. And they're doing this by frequency modulation. So they could send one message at this frequency, a lower frequency. This apparatus had a thing like a mouth organ. Like, if you open up a mouth organ, you see little reeds in there.
Yeah.
And one day, Watson was tightening up one of the screws on one of the reeds, and it slipped. And the audio signal was transferred into the next room, into Bell, where he was.
Yeah.
So he then decided he was going to change his tactics. He'd been backed by his future father-in-law to do this.
Yeah.
He said, father-in-law thought that this was a bad idea, that nobody was going to be interested in the phone.
Who'd want to talk from one distance to another when you've got dit-dit-da-da?
Exactly, yeah. And he thought modifications to Morse was more of a sure thing.
Yeah.
So Bell had to, when he put it in his patent application, eventually for the first phone, he had to make it sound like it was a telegraph. The language he used was very general, so his father-in-law wouldn't cop on what he was doing. But eventually, when they got the second phone going, then he could be honest with them, and they told him everything lined up after that.
Is there any record of that first accidental communication when Watson was in one room and his assistant was in the other, and he was like, I can hear you? What were the magic words? Was it something profound?
No, it was... actually, there were two accidents. One accident was that, the one I described, and this one was when Bell spilled some acid on his lap and said, Watson, come here, please. That was the one, Watson, please come here. That's the famous quote for that second accident.
Ain't it funny? It's just something that happens, a complete random thing, and it twists and turns. The book is full of stories of radio communications, early communications, and then telecommunications, and right up to today. It's very comprehensive and fascinating, I have to say. There's some great other stories I wanted to ask you about. There was an example in the book about laying the first undersea cables between Ireland and Wales, I suppose. And there were some quite unique engineering challenges in that. What were the engineers of 200 years ago? What was the problem they were trying to fix with that cable?
Well, I think you're referring to the cable between Kerry and Newfoundland.
There was one before that, I believe, between Ireland and the UK, but same problem, I think, as well with the transatlantic one, yeah.
When the information was transmitted here, there was a little pulse of electricity going through this cable.
Yeah.
By the time it got through to the far side, it was so smeared out that it was difficult to decipher that pulse.
Oh, okay.
It was flattened out because of the capacitance of the transmission line under the Atlantic Ocean, 3,000 kilometers long. It was delayed as well and smeared. The engineers at the time thought that if they increased the voltage, they could solve the problem. But this wasn't the case, because the guy called Lord Kelvin, the temperature Kelvin scale, he was around at that time too.
Okay, yeah. And that's him, is it?
Yeah.
Yeah.
And he actually had a bit of a dispute with the engineer, he told the engineer, don't increase that voltage. And he increased it, and the cable failed for that reason. The voltage was so high, couldn't take any more, and it broke down. So what Kelvin actually discovered was the equations which governed how the pulse went through the line were related more to heat, the heat equation, and nothing got to do with electronics at all. That's how he knew for sure that it was going to work if they made the insulation thicker.
That's amazing. So the engineers at the time didn't know this because they'd never done it before. So that was trial by error, even though the facts were already out there in the world.
Yeah, well, this happens a lot in engineering where sometimes practice can come before theory. Biggest example of that might be Michael Faraday. He didn't have a very strong theoretical foundation, but he was one of the greatest experimenters of all time. He was constantly watching out for these little mistakes or these little tricks. He was the guy who discovered magnetic induction. In other words, how do you create electricity? He's the first one to create alternating current. So later on then in his life, when he saw Maxwell's equations were James Clerk Maxwell. He was a genius. He died young, and he produced these 4 equations which show you how electrical energy is transmitted through the air. When he saw these equations, he immediately knew they were like a summary of his whole life, these 4 equations. And he wept, and he was very emotional about that.
So it's something like, he was learning as he went along and developing his equations as he went along, which is interesting because in Silicon Valley and in telecommunications today, I mean, there's a phrase, move fast and break things. And that seemed to be how they learn. That's what they're doing with AI. Look, just put it out there in the world and we'll see what happens and we'll regulate it afterwards. That kind of thing. Exactly. And they were doing that 200 years ago when they were laying the first transatlantic cables. It's just...
Yeah, they were. And if they didn't do that, it would take much longer. You can't wait for the theory to be written first.
Yeah.
You got to do things. You got to do things and make things happen first sometimes.
And write about it later. I think another good example of that is possibly the invention of the automatic telephone switch, which I believe involved a funeral director.
Oh, yeah, that's right. Because when first the telephone was invented, you needed some way to get people together for people to connect. The first system used was just manual, just patch cords.
Yeah.
So this guy called Strouger, he lived in the Midwest in America. He was an undertaker, actually. His competitor's wife was the operator in the local exchange. So when a call came in for looking for an undertaker, he wasn't going to get that call, was he?
She put it through to her own husband.
Yeah. I can't even imagine what his thought process was, but he put a small model together of an automatic switch, which in his system, you had a rotary dial. As the rotary dial went around, you got these pulses, and the pulses actually they move a sound
in a certain sequence. Yeah.
Tick, tick, tick.
That's what the clicking sound was.
Yes. It was
Wow, that's amazing. I'm learning so much.
So that was the very first automatic switch. That was about 1891, I think.
I was about to ask you that because 1891. Then you fast forward 90 years, all right, to Ireland in 1979, shortly before, I think you might have been just getting involved at that stage. But anyway, in 1979, the Irish telephone system was a mess. And if I'm not mistaken, 50% of exchanges in Ireland were still manual in 1979.
That's right. So the government, I think Taoiseach Jack Lynch and the Minister for Postal Telegraphs was Albert Reynolds. They asked for this consultant to come in, and he wrote this report called the Dargan Report.
Right.
It recommended that he split the post and telegraph into two parts, one for post and one for telegraphs.
What did they call the telegraph side of it? I know post was just on post, but what was the telegraph side?
Telecom.
Oh, it became Telecom in the early 80s. Okay.
So they made a deal. Albert Reynolds, he got Ericsson and Alcatel in the same room, and he told them he got this deal together to change the network so that we could get rid of these manual switches and these old technologies and replace them with digital technology, digital switches. When you walk into a room where the digital switch is silent, when you walk into a room with crossbar or with Strouger or step-by-step, those old technology based on relays and solenoids, everything you call you could hear it. There's a sicking as it passes way through the matrix. They did amazing work. I think by the time Telecom was actually formally created in 1984, they already had 30% of all the exchanges done. I mean, they were all digital. That was a good start for Telecom, you see.
That was a great start considering the mess that was in the late 80s. 100,000 people just on a waiting list. In Ireland, 100,000 people on a waiting list for a telephone in 1979. It sounds crazy. When did you come into the picture then, Brendan?
Early 90s. I joined Telecom in September 91. And at that time, almost the entire network had already been digitized. But the part from the local exchange to the customer was still analog. So this is where ISDN came in. And GSM, actually. Yeah. ISDN and GSM, that's the mobile version of ISDN. They use the same protocols, the same types of signaling. So to the engineer, they look very much alike. But of course, they're very different in reality to the customer. I was in charge of the ISDN field trial at the time, and we worked together with the marketing people to make people aware that this is coming along. ISDN was more for business people, I think, than for residential users.
We used it extensively in radio at the time because we would have voiceover people in the States. And the way it would be done is they would do the recording. You'd listen on the telephone to make sure they got the pronunciations right. And then they would put a tape in the post and it would be FedExed and you'd have to wait 24 or 48 hours. Then ISDN came along, which is it integrated digital services network, something like that, is it?
Integrated services digital network.
I said, there you go, Grant. All right. But anyway, all of a sudden, I had this box in my rack in the studio and I was able to dial a number of another ISDN, somebody in the States, and he came through my speakers in full proper quality. It was amazing. We were able to do the recording there and then. That at the time was life-changing. And now when I see my wife talking to her sister in Melbourne, Australia for 4 hours at a go, with video and everything, it's huge how we came on with. So ISDN was one of your things. Were you involved in the early days of the internet as well?
I didn't really have much to do with the internet. I mean, once I moved across into our consultancy division from the engineering side in about 2000, it was only then that I really discovered how important and how far-reaching this new protocol, this TCP/IP protocol, was going to be. I was on a course one time, I remember, in the telephone network, each individual exchange has their own routing table. Somebody's got to go in there and enter that routing table to make sure that the calls can be routed through the network. I was very impressed with IP because it has this ability to share the routing tables automatically from one node to another. Of course, the internet initially had been designed to survive a nuclear exchange. Think tank called the RAND Corporation in America, and they asked this guy, Paul Rad, to figure out what was the best type of network that could survive this catastrophe. He invented packet switching, really, that way.
So if I get this right, you're talking about it's packet switching, okay, which is a digital way of routing something. So like many of the other things you talked about, if you had, say whatever, the 8 or 10 computers in a network, and that was the internet, and the two middle computers were gone, the packets, instead of routing their way through the central computers, would find other ways around. and it would do it automatically. And therefore, you had the redundancy built in. And even if there was a nuclear war and certain servers were taken out, the internet would continue to operate.
Yes, this is true. That's very well said there, Dusty. If a link wasn't available, then the route table would be automatically updated from other nodes in the network.
And then keeping in that line with automatic switching and digital technology and everything. So the internet was coming along in the early 90s. Back in that time, if you wanted to connect to the internet, you would have to have a modem in your computer, was called, and it would be connected to your telephone line, and you get all these squiggly noises and stuff like that as it connected. We're way ahead of that now with broadband and fiber technology and stuff like that. The rollout, you were saying, from the late 70s with the telephone network, was the rollout of broadband in Ireland as successful a rollout?
It all happened very quickly, actually, because I remember in about 2000, this technology called ADSL appeared. Instead of making a phone call, using your modems to the network, and then, it was expensive because it was a time-based thing. ADSL gave us the ability to connect customers maybe, fairly close to the telephone exchange, and that bypassed the telephone network altogether. It was a customer, just like today. This goes into a different broadband network. ADSL was the first of those technologies. The first VDSL came along. ADSL means asynchronous digital subscriber line. Then VDSL, very high speed, and then it went all the way up until today we have fiber.
Yeah, and then you got fiber to the cabinet, and then fiber to the premises, and all that kind of stuff. So can I ask you, as an engineer, all of these things are changing, because everything we've spoken about has changed really in the last maybe 30 years, which in the grand scale of things is not really that long, especially when you're talking about massive, infrastructure. How did you handle going from technologies that's just getting faster and faster and requires a new rollout? Oh no, we've another new rollout. Now we've got another new rollout. Did your head not, fry?
This is one of the problems with networking, because everything, it's all about different technologies working together. If you change from one technology, one part of the network, it can have implications for everywhere in the network. And that's one of the reasons that testing and protocols and the standards organizations, for telecoms, they're very, very important. And ISDN was nothing but a standard. I mean, at the beginning, ISDN was just something that they wrote down on paper. And then afterwards, they came into reality. Same with GSM, of course, and 4G. And these standards ensure that that all operators in the world have something to work towards. We're not held up by, if you imagine lots of proprietary hardware, lots of proprietary protocols, then you could be held up to ransom by your vendor.
You weren't able to move fast and break things. Is that what you're telling me, Brendan?
Yeah. When you have standards like that, you're operating to something very exact, test cases to do, and they're all written down first.
Yeah. Listen, let me get back to the book, because we're kind of up to the today part of the book, and you touch on subjects like cybersecurity. What do you think is the single biggest security problem that you see in today's large-scale telecom networks?
I think it's probably something like spam text or spam calls, which are now being aided by artificial intelligence.
Yeah.
Now it's possible for somebody to get a voice recording and use that voice recording then to make a phone call to somebody and say something like, "Oh, I'm stuck here. I need some money. Please help me."
Yeah.
These voice recordings, they're becoming so realistic. It can be hard to know.
You don't know what to believe.
Yeah, and also the other thing that artificial intelligence is doing, it's making it easier for those bad actors to do this.
Yeah.
Because now, instead of needing 100 agents making calls, sending text messages, they have these AI scripts which can do the same thing.
Do you think the responsibility for cybersecurity rests more with the provider or with the customer? I mean, is there anything technically that can be done, that side of things, to cut down on cybersecurity?
Well, the operator can make sure the calling party number is correct.
Mm-hmm.
If that was followed through, I mean, you would see a call coming in from the Far East, maybe somewhere like the Philippines or Malaysia or somewhere, or maybe and they say, "Oh, I don't know anybody there." That's probably
Spam. Boom. Not answering. Yeah.
they can make the numbers look like Irish numbers now, but still, I think the operator has a responsibility to make sure that the number that the customer sees before he answers the call, that number is correct. We can also do similar things with spam text messages in that we can use AI to determine whether a message is probably okay or not okay, just by pure pattern recognition.
Yeah. That's good. I hadn't thought of that.
Yeah, I mean, some people say that the operator needs to see into the message itself,
That's a whole privacy issue. That's
Yeah,
a whole
privacy issue,
privacy
yeah.
issue.
Yeah.
You're delving into some dark waters there. And I know that there has been talk recently about European governments wanting the ability to look at WhatsApp messages. And initially they're saying it's for, kind of a child protection, but that can be expanded out to anything. I mean, that's a whole other debate. Listen, let me go back to the book. It's called The Evolution of Telecommunications. As I say, you take it from da right up to cybersecurity and AI and everything today. What motivated you to write this book, Brendan?
A number of years ago, I got this message. I was on the circulation list, and the message attachment was a PDF transcript of a talk given by the head of P&T in 1961. He gave this talk to the engineers in Dublin. And I went through this, and what amazed me was the language, the English in this. It was all so straightforward, all normal. And I could understand what the guy was saying. Very little jargon, because engineers nowadays, we're guilty of making things very complicated and making things not accessible for normal people. We use too much jargon, I think. And I thought to myself, my God, someday when I'd like to write something simple and clear to explain, what we do as engineers, because it's a bit of a barrier between us. And also, I've been a big fan of these popular science books from the 80s and 90s, like Selfish Gene or by Richard Dawkins. And actually, my favorite book is 1984, George Orwell. Again, very simple, clear language.
Yeah, great book.
I took redundancy from Air a year and a half ago, and then I had no excuse to do this,
Do you think it's important? I find history and the way things came together and the fact that history does repeat itself. So we were talking about, kind of moving fast and breaking things, but with engineers from 200 years ago, it's still happening to this day. Do you think that sharing the knowledge and the experience you have is important for future generations of engineers?
I do. I mean, in the past, there was no barrier to do work in engineering. For example, Morse himself was one of the best portrait painters in the world. He actually has a painting in the Louvre in Paris. He was that good. And he was motivated when he heard his wife had died.
Yeah.
And when she was buried, before he even got the message. So he got home and found that, he said, there must be a faster way to exchange information. So, yeah, I hope that the book itself can inspire one or two people in this country to enter engineering and know that it's not completely about ones and zeros. I mean, the history of engineering is very interesting, and I tried to make it interesting in the book as well.
I think it's great because you're looking at stories from way back when, and you're looking at engineers and the challenges that they were facing and how they solved them, and the hoops they had to jump through in order to fix it. So seeing that and seeing how people think is amazing. But I think it's also a book about change. And I mean, you had people working for you when you were with eircom and Telecom Éireann, and you're dealing with constant change. Is there anything you can share just from your own experience? And I'm talking about leadership now, okay? What kind of leadership lessons did you learn when you were working with teams and going through these big technological shifts?
I assembled a team to look at this new technology called IMS, the IP multimedia subsystem. It was a voice over IP system for operators. I always liked to work in small teams, no more than 4 or 5 people, where everybody was completely engaged and I would always start off a new project with some sort of a workshop. You see, how much do we know about this topic? How much do we not know about it? These workshops were like, all the ideas were put together at the beginning, and we then went on to look at the new technology. Small teams where everybody was honest with what they knew and they didn't know. That's my way to do things, I discovered.
And did you find that working with other engineers then there was a certain curiosity and how can we do this? Kind of a feeling in the air.
Of course, yeah. Yeah. We engineers were very inquisitive people. We do like to break things from time to time. That's necessary, because then you have to fix them afterwards. Engineering is the art of giving something flesh, in my opinion.
Brendan, can I ask you about your work experience and working your way up the ladder, all right, about change? Because there's two things I want to do. I want to talk about change within a career and then transition to something completely different, because you have done both, okay? What do you think is an effective way for an engineer to advance their career when you're in a huge organization like eircom?
Yeah, first thing you got to do is you make a decision about what track do I want to take. Do I want to advance my career as an engineer, or do I want to go into management? For me, it was to be an engineer. I wanted to be the best engineer I could be. And I always had people available to work for me. But formally speaking, they were working for somebody else. If I could do something myself, I would on my own. And if I was working on a slightly bigger project, I would also go out there and get some people. So those two tracks are valid. One for pure management and the other for engineering. I would say that I know more about my own track than the other side.
Do you ever regret not going into management?
No, I don't. Nowadays, management is far flatter than it used to be. When I joined first, I was in Telecommunications the first time. I was in a group, and then we had a manager there, and that group was part of a division. And that division then was part of something else, a department. I think there were about 10 layers of management in Telecommunications at that time. And now there's only maybe 4 or 5 because people have been given more responsibility, I think, nowadays. More responsibility is falling onto the pure engineering side.
And then can I ask you then about transitioning to a new phase where you're getting out of a large, nice, safe, paid salary or whatever, and you're transitioning into a new phase of your life? You said that you left the company 18 months ago and now you're into a whole new phase of your life and you've... like completely changed. You've gone from engineer to author. How did that transition come about?
I'd always been interested in writing. I was one of these people. I always wanted to do something, but I never had the time to do it. So for me, the transition wasn't that hard actually. The problem for me was to establish a new routine. So when I was writing the book, I would come down to the office every morning as if I was going to work. That sort of helped me in the way that. A bit like compound interest, You don't see one day, another day, one day. Time goes by and suddenly you have one chapter. You show the chapter to somebody and they say, okay, not bad. Then you get courage, you get that gives you energy to move on to the next chapter. And so on, so forth. I mean, I brought the first draft of the 4 chapters to my Christmas party. I can't even believe I did that, but I did. We were having some drinks and I went in with a folder. I mean, I said, what do you think about this, guys? When you're writing something this big, you have to be a little bit obsessed in today's world. I mean, today's world is for browsing and for skimming and for, the internet. It's seconds of attention. Yeah, it's very hard to get the focus to. But I did. I was a bit like a clock and hen, I think. In that I was very, very honed in on one thing. And speak to my wife. She might say I disappeared for few months.
But you got the head down and you did it. Listen, I think your personal story is a fascinating story, but the book and the way you've written it and literally gone through the history of telecommunications from the year dot right up to today is just amazing. If you're interested in learning more, Brendan's insights into the history and future of telecoms, you can find a link to his book. It's called Evolution of Telecommunications. You can order it super easy on amazon.ie and I've put the link in the description area of this podcast. But for now, Brendan Kearns, thank you so much for joining us.
Thank you, Dusty. Been a pleasure.
We hope you enjoyed our conversation today. If you know another engineer who would appreciate these insights, please do share this podcast with them. They can find us very simply by searching for Engineers Ireland wherever they get their podcasts. This episode is produced by dustpod.io for Engineers Ireland. For advanced episodes, more information on the latest trends in infrastructure or career development advice, you can find a wealth of resources on their website at engineersireland.ie. Until next time, from myself, Dusty Rhodes, thank you for listening.